Mercury does not have an atmosphere to protect you. It has a temperature swing of 1100 degrees Fahrenheit between its day and night sides, the largest of any planet in the solar system. Venus has been called the most dangerous world for decades. Every documentary, every textbook, every space agency ranking puts Venus at the top. They are wrong. Mercury is the planet that would kill you faster in more ways without giving you a single second to react. It sits 36 million miles from the sun, yet its night side drops to minus 290 degrees Fahrenheit. The same rock, the same day. The reasons this world is deadlier than Venus are not speculation. They are physics. Every one of them has been measured and confirmed. Stay with this, because what comes next permanently changes how you see our solar system.
Mercury is only slightly larger than Earth's moon. Its diameter is 3,032 miles, smaller than the continental United States is wide. Yet this is not a small problem. Its surface area is 28.9 million square miles of some of the most hostile terrain ever confirmed by human instruments. The Sun appears 3 times larger in Mercury's sky than it does in ours. At perihelion, its closest orbital point, Mercury is only 28.6 million miles from the Sun. That is 65 times closer to the Sun than Neptune. At noon on Mercury's equator, you would be standing on rock that reaches 800 degrees Fahrenheit. The ground beneath you would glow. The solar radiation striking that ground is 10 times more intense than anything Earth's surface ever receives. Something with no atmosphere cannot stop any of it.
The first reason Mercury kills you before Venus does is radiation. Mercury has no magnetosphere worth mentioning. Its magnetic field is only 1.1% as strong as Earth's. On Earth, our magnetosphere deflects the solar wind. On Mercury, nothing deflects it. Solar energetic particles hit the surface directly, with energies exceeding 10 million electron volts during solar events. A human being exposed to that dosage without shielding would receive a lethal radiation dose in under 4 minutes. By comparison, the radiation threat on Venus is significantly reduced by its dense atmosphere, acting as a buffer. That same atmosphere that makes Venus a furnace also absorbs solar particle radiation before it reaches the surface. Mercury offers no such trade-off. The radiation that would end your life arrives invisibly, instantly, and with nothing standing between you and the sun.
The second reason is thermal shock on a scale no engineering solution has ever been designed to survive. Mercury's temperature swings 1,100 degrees Fahrenheit between the sunlit and shadowed sides of a single rock. For comparison, the material stress caused by a temperature change of 200 degrees Fahrenheit is enough to crack aircraft-grade titanium. No known suit material, no alloy, no composite survives an 1,100-degree differential, sustained without interruption. NASA's Messenger probe, the only spacecraft to orbit Mercury, had its thermal protection as the primary engineering challenge of the entire mission. The spacecraft's sunshade reached 700 degrees Fahrenheit on its sun-facing side. Engineers described it as the most thermally hostile environment any NASA probe had ever operated in for an extended period. That probe had no biological tissue to protect. You would not be a probe.
The third reason is the one nobody expects: shadow. Most people assume the shadowed craters on Mercury would be the safest zones. In reality, they are among the most dangerous places in the inner solar system. Scientists confirmed in 2021 that permanently shadowed craters near Mercury's poles contain water ice that has existed for billions of years. Temperatures inside those craters drop to minus 370 degrees Fahrenheit, colder than Pluto's surface. The same world that reaches 800 degrees Fahrenheit in daylight drops below Pluto temperatures a few miles away. No environment management system conceivable today could handle both extremes simultaneously. The shadows that appear protective are lethal in the opposite direction. The twist is this: The very feature that made scientists most excited about Mercury as a resource destination is the same feature that makes surviving there geometrically impossible.
Consider what 800 degrees Fahrenheit means in terms you know. Lead melts at 621 degrees Fahrenheit. Aluminum melts at 1220 degrees. Mercury's daytime surface sits squarely between them, hot enough to melt most metals, yet not quite at aluminum's threshold. Your body's proteins begin denaturing irreversibly at 130 degrees Fahrenheit, the temperature of a hot tub that would already kill you in minutes. Mercury's surface is 6 times hotter than that. Now consider the cold side. Liquid nitrogen boils at minus 320 degrees Fahrenheit. Mercury's permanently shadowed craters are 50 degrees colder than liquid nitrogen. You would need a system that simultaneously manages an environment 6 times hotter than death on one side and 50 degrees colder than liquid nitrogen on the other. Those two zones are separated by a walking distance. Nothing humanity has ever built exists in that engineering space.
What scientists recently confirmed changes everything about how we understood Mercury's danger profile. New analysis of data from the Bepi-Colombo mission, currently en route to Mercury, arriving in 2026, has revealed that Mercury's exosphere is far more chemically reactive than previous models predicted. The exosphere is not an atmosphere in any protective sense. It is a thin shell of atoms, sodium, oxygen, hydrogen, calcium, blasted off the surface by solar wind and radiation. Scientists now confirm this exosphere contributes to surface chemistry that actively corrodes materials at the molecular level. Metals do not just melt on Mercury. Under certain solar wind conditions, they are chemically stripped apart at the surface. No one is talking about this because the headlines focus on the water ice. The water ice is extraordinary. The corrosive exosphere surrounding it is what actually closes the door.
Before this next fact, understand what you have heard so far. Radiation, thermal extremes, corrosive chemistry, each one is sufficient independently to end any human presence on Mercury. Now consider what connects all three. Mercury has a day that lasts 59 Earth days. That is not a misprint. One Mercury solar day, sunrise to sunrise, lasts 176 Earth days. Mercury orbits the Sun faster than any other planet, completing one orbit in 88 Earth days. But it rotates so slowly that the Sun appears to rise, briefly reverse direction, and continue rising. This means the solar radiation, the peak heat, and the direct corrosive solar wind exposure are not brief. They are sustained for the equivalent of months. A human being standing on Mercury's surface would be exposed to lethal solar radiation not for hours, but for the equivalent of an Earth summer without pause.
What Mercury represents for humanity is not merely a world we cannot visit. It is a limit marker. It defines the inner boundary of where biology survives in this solar system without extraordinary engineering. Mercury sits at the edge of what the Sun allows. Everything inside Mercury's orbit is, by physics, off limits for life as we know it. This matters because Mercury contains some of the densest concentrations of heavy metals in the inner solar system: iron, sulfur, magnesium, silicon. These are resources a spacefaring civilization would desperately need. The fact that we cannot reach them tells us something profound about where our civilization currently stands. We are a species that can see resources essential to our future, confirmed, mapped, documented, and have no physical mechanism to retrieve them. Mercury is not a dead end. It is a reminder of how far we still have to go.
Here is the cosmic irony this planet hands us without apology. Mercury is the closest planet to the Sun, yet it is not the hottest. Venus is. Mercury is the smallest planet, yet it has one of the largest metallic cores relative to its size, taking up 85% of its radius. We have sent only 2 spacecraft to Mercury in all of human history, Mariner 10 and Messenger. We have sent 5 rovers to Mars. Mars is celebrated as humanity's next destination. Mercury, a world we know less about than almost any other, is treated as irrelevant. We stare outward at Mars and Europa and Titan. We almost entirely ignore the world sitting closest to the star that makes all life on Earth possible. The most dangerous known place in our solar system is also the most studied least. That is not an oversight. That is a choice.
Everything you have just heard about Mercury leads to a question this channel cannot answer, and neither can anyone alive today. If a planet this close to a star becomes this hostile to life, what does that say about every star in the universe? There are 400 billion stars in the Milky Way alone. Each one has an inner boundary, a zone where radiation, thermal extremes, and corrosive chemistry prevent biology from surviving. Most of those stars are hotter and more energetic than our Sun. Their inner boundaries extend further. The habitable zones around them are narrower. If Mercury tells us anything universal, it is this. The cosmos spends most of its energy creating environments where nothing lives. The question that remains permanently open is whether what we call life is a rare exception to a rule written in physics, or whether we simply have not looked in the right places yet. Mercury does not need to be the most famous planet to be the most important lesson our solar system teaches about survival. It is a world that breaks every assumption quietly, without drama, simply by being what physics made it. The full comparison between these two worlds is not finished yet. If you want to keep going deeper into the parts of space that science confirms are beyond our reach and understand exactly why, subscribing means you will not miss what comes next.
This channel exists because these questions deserve real answers. We will keep finding them.